Alright, hell yeah. So this was sent in by a German student, and he said none of the students could do this problem. And he did a pretty good job of nailing it down, because I spent about 5 hours thinking this was like going to be the most complex thing in the world. But still, it still had the elements of like, hey, find the equations, find the unknowns. And so that's how this student started out. So this problem, we need to get the solutions in form of, square roots of numbers and making sure the denominator's rational. So I'm going to highlight that. Now it says, it gives you the solution, so that's cool. And so this thing is like, some sort of, let's say it's a sine, or I don't know. And then someone's going to put a huge weight on it. We have a support here, a couple supports here. They're all hinged. So you can just imagine maybe a welded metal frame, 5 meters, 2 meters, kind of get the gist. This is super heavy. This is going to be L, and I guess here's the full problem statement. L is 5,000 newtons. But we just need our answers in terms of L, so we don't even need to know what L is. We can just say it's L. Cool. And with a pulley, the tension in the pulley is going to be the same in both directions. So even here, and then there's kind of, I'm not going to go over it, but there's an idea that you can get the forces, on the corner. Just because the pulley has dimension, you can say that the forces act directly on the corner, down, and then at 45 degrees. Cool. All right, so then we have, the direction. Well, let's get this one is in compression, so that's going to be towards this object. S2 is in tension, it's going to be away from the object. Cool, and then S3, this one is going to be in compression. And then a rope can only take tension, so it's that way and this way. Cool, I'm not going to draw the arrowheads on those. Then you're going to come in here and maybe just draw a little, because it gives you, anytime it gives you the dimensions of the setup of the members, perfect, hell yeah. We're going to write those in. The simplest way to do it is like, okay, we're going to go 2,000 up, 2,000 over. That looks like a 1-to-1 ratio. Now, how do you get the hypotenuse? We use Pythagorean's theorem. 1 squared plus 1 squared, that's going to be 2, and then we take the square root of that to get that dimension. So this is going to be the square root of 2. This is going to be down 1 over 2. So 1 squared plus 2 squared. Okay, 2 squared is 4, so then you're going to have 1 plus 4. This is going to be the square root of 5. All right, hell yeah. Now the take-home point here, I'm just going to go over this fairly fast because it's good for me to also do that as well. We're going to have a downward component. And the downward component, we want to kind of know the percentage. I think of it as a percentage. You might think of it as a fractional, a fraction of the hypotenuse. But either way, you're going to take this dimension 1 and divide it by the hypotenuse. That's going to be the percent. So I'm just even going to write percent is going to be 1 divided by the square root of 5. So that is the percent in this direction of whatever this is. You know what I mean? So these are just the direction of the hypotenuse. And this isn't even, this hypotenuse direction, this is square root of 5. That's like about 2.2. So that has nothing to do with a unit vector. It's actually a substantial vector. But if we want to get a unit vector, or the percentage that might be in this direction, this is how you do it. You take this divided by that. Cool. All right, so now we want to just do the sum of the forces in the x, sum of the forces in the y, sum of the moments. So this student did that and took the moments about A. And just as a tease, like I did it this way. But it took me, I did a 5-hour video. So this is not the 5-hour video. But when I got to the nitty gritty, I was like, okay, some of the forces in the x, some of the forces in the y. And I was like, where's the best place to take a moment? Best place to take a moment is where like two things intersect. But it does make it's not as easy as pi. Once you take the moment, I took the moment from that point, I called it D. Then the only unknown, because you know L, you know what I mean? You're going to have a component this direction, another component of this direction. You're going to have two components This one fully, this one at a 45 in that direction. This 45 is also in that direction, all providing a negative moment about D. It has to be supported by this positive moment. The only other force is S1, but you don't know this distance. You know what I mean? That distance, that perpendicular distance, and then so the idea is to use, well, I shouldn't even be going over this, but it's good. You know what I mean? Yeah, I shouldn't be going over it, but you have to use a dot product, whatever. You know what I mean? I think it's more complex. I don't think I could do that first try every time, but it's fun to be like, oh yeah, I remember like a dot product being something. But anyway, so we're just going to do this classic, but it's going to be a little bit hellish because we're going to have 3 equations and we're going to have to get it down to 1 equation. And we're going to have all these square roots. And we're going to have to rationalize the denominator. So that's the goal. Like once we get these equations, we're going to see which ones we want to combine together. That's a very important thing. And then we're going to rationalize as much as we can and simplify as much as we can as we go. And hopefully we're just not writing the same thing 1,000 times. So here we go. All right, so we have sum of the forces in the x is equal to 0. So we have this component of the S1. And I think I will write these components. If this is tail to tip, we have a component in this direction. I like to kind of just do dotted lines. And then this one, tail to tip. You could use the parallelogram method, so you could go this way and that way to represent this vector, or this way and that way, or you could just, you know, do this. That kind of represents this vector. If we go over here and just say, well, you know, let's just say this is the vector in this direction, that's going to be L. And then over here, we're going to have about the same magnitude. But even right here, you're going to have 2 components. It's going to start from, and we're going to say it starts from this point, but just who cares? We're going to put that point right there. And so we're going to go down. So that's going to be the component that way. I think that's helpful. Cool. And then we still, on this one, even have the 1 square root 2. Okay, now how to do this kind of just in one swoop. We're going to say this component in this direction. We want the percentage of S1. I mean, so right now you could just say S1, you know what I mean, S1. But now we want to know the percentage. That's going to be this 2 divided by the square root of 5. So we have 2 divided by the square root of 5 S1. And that's going to be in that positive direction. Over here, this one's going to be a negative. So we're going to go negative, do that same thing. We have 1 divided by the square root of 2. 1 divided by the square root of 2, and this is S2. Cool. And then this S3 is vertical. We don't have an X component. So, and then this component's vertical too. So the only other component we have is this, and it's 45. Again, it's 1 divided by the square root of 2. It's also in the negative direction. So we're going to have negative, and that's going to be L. This is equal to 0. Now, you might as well rationalize right off the bat. So, how to rationalize? We're going to multiply this top and bottom by square root of 5. Multiply this by the square root of 2. Now, I mean, I wouldn't, like he had a good idea of like, you know, maybe should I just use decimals? And sure, like I'm actually going to do a separate video where square root of 5 is close to 4. Just make it 4 and move on with life. Square root of 2, I don't know. Let's say it is 1/2. You know what I mean? That's going to be 3/2. Make it 2/3. You know what I mean? So there you go. 1 divided by the square root of 2 is just 2/3. And then just have simple fractions and get to an answer and just double check on reality that you actually did all the steps right. All right, sweet. So yeah, and then you know look how busy this is. But when you rationalize, this just becomes 5 on the bottom, and then we got 2 square roots of 5 on the top. It doesn't seem like we did anything, but you need your bottoms to be the same. And some terms won't have a square root. That is why you rationalize, because some terms won't have a square root. Now, you can't add, and we'll get into that. But anyway, so there we go. So we have S1. We have minus the square root of 2 S2 divided by 2. Minus, this is the square root of 2 divided by 2. And this is L. Cool, hell yeah. I said this was going to be equation 1, and booyah. So after we get 1, 2, 3 equations, we're just going to go to white paper, just because we have a lot of busy work to do. All right, this was sum of the forces in the x. Now we want to sum the forces in the y direction. That's going to be equal to 0. So this has a downward component, so we're going to be negative 1 divided by the square root of 5. So even right here, I could just start to rationalize this. If I was on my game, I could be like, well, isn't that just the square root of 5 divided by 5? Because I'd multiply by the square root of 5 down here, multiply by the square root of 5 up here. But even I'm not at that level, you know what I mean? So I'm just going to say 1 divided by the square root of 5 multiplied by S1. Cool. And again, these dimensions were just to give you the percentage in that direction. Now 2 is not the percentage, but 2 divided by the hypotenuse. That's going to be the percentage of this. You know, another way graphically to look at it, let's say this is 100%. Cut this in half, always do that. Always take your hypotenuse, cut it in half, because it gets you in the habit of being like, oh, I get it. Like this side is about the same as half. Well, cool. So 1 divided by the square root of 5 must be pretty close to a half. And the square root of 5 is pretty close to square root of 4, which is 2. So that's pretty close to 1/2. Hell yeah. All right, so we have this component, it's going to be down. This component's also down. So we have minus 1 divided by the square root of 2, S2. This component, S3, is up. I'm going to put it in right at the end. I just did that in my notes. But keep in mind, we're just going to go right over here. So we have an L component down, so we have minus L. Now this thing is going that way. So it does have a downward component. It's at a 45, so we have minus 1 divided by the square root of 2L. Now I'm going to keep these terms separate because one has a square root of 2 and the other doesn't. You know what I mean? This is, even though this both has a factor of L, it's still apples and oranges. Anytime you have a square root, like consider that an orange, and then everything else, I don't know, just a nice little apple. All right. So let's double check because we have this S3. So we have, and that's going to be positive S3. And now from here, I mean, in my longer video, right off the bat, I was like, hell yeah, S3 is going to be way big. Negative, 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 negative. S3's got to make up for that. Hell yeah, and that's going to be equal to 0. And again, let's double check. So we have that component down, that component down, that component up, that component down, and then this component, just the downward part. All right, now we got to do, and we got to, let's rationalize and make this just a little bit nicer. So we have minus the square root of 5 up top, 5 down below, S1. Better write just a little bit more nice. We have the square root of 2 divided by 2, S2. This is just good to go, minus the square root of 2 divided by 2L. And then we have this S3 term, plus S3 is equal to 0. Okay, hell yeah. So I said that was my second equation. And the student did the same thing. You know, he got the 3 equations, but then it's just like, I think you get to a point where you're just like, ah, damn it, I don't want to actually, like the second you start grinding and you just make a simple error and then you're just like, nah, this sucks. Anyway, so we're going to do the sum of the moments about A. And that's going to be 0. Cool. So if I put my finger on A, all the forces that go through A, so this cancels out, you know what I mean? So we just have, this is busy. Because if I'm summing the moments about A, I have, and this component goes through A. So let's do this. I only have one component, and that's going to be 1 divided by the square root of 2, S2. And we have, so it's going to be in that direction. It's going to be a negative moment. And our distance, and here's a great time to be like, what the hell are you doing with these distances? So these are millimeters, so we're just going to say this is 2 meters. This is 5 meters. This distance is 2.5 meters. So my moment for this one is 2.5. And because we have fractions galore, this distance is going to be 5 over 2. This is the only one that you actually have to put a fraction on. So hell yeah. So I'm going to put that out front. 5 divided by 2. It's a negative moment. So we have This force right here is going to be negative. The distance is 5/2. 1 divided by the square root of 2. I mean, yeah, don't put a decimal here when you need to get towards the fractions, and not you specifically. I'm just, even for myself, like I'm already doing this problem. Like I've already done it twice. Messed it up once. You know, even from this, I did a 5-hour the way I wanted to do it, and then even just going through this to be like, oh yeah, I see where it gets messy. Yeah, you just make little errors. Okay, hell yeah. So we have the moment of that one. Now we have the moment of, let's do this S3, I think, I don't know. We do the, it doesn't matter. Let's do the S3. So now we're going to have a 3, so we have a positive plus 3 S3. Cool. Now we're going to go here. So we're just going to do this one. It's going to be 5 negative 5L. So we have negative 5L. So some are simple. Now this, don't mess up this. I messed up this quite a bit. This has 2 components. One's that way, one's down. Let's do the downward one first. That's still a distance of 5, so we got minus 5. Its component is only just 1 divided by the square root of 2. So we just have the square root of 2L. Cool. And then it's got a component that way. And that's still a negative moment. And so we're going to have, the distance is 2. So we have minus 2 divided, and this is 1 divided by the square root of 2, which is just put the square root of 2 down there, and that's L. And that's going to be the moment. This 2 is the distance. 1 divided by the square root of 2 is the percentage of L, the tension. Same thing here. 5 is the distance. 1 divided by the square root of 2 is the percentage of L, because it's at a 45. This is 5. That's the distance. L is just 100%. Same thing with 3. S1 is 100%. Here, we just had this component, so it's going to be S2, but it's going to be a 45. It's going to be 1 over the square root of 2. That's going to be a... And 1 divided by the square root of 2 is the same thing as the square root of 2 divided by 2. Once you rationalize this, you put a square root of 2 up top, square root of 2 below, you get square root of 2 divided by 2. That's going to be 1.4 divided by 2. That's 0.7. You know what I mean? So it's good to know some of the decimal forms of these. All right, hell yeah. And the 5/2 was the difference, the distance. So that one is kind of worth going over, just to make sure. And we should rationalize. But maybe now we'll just kind of go to a separate sheet of paper. And even, yeah. Well, bummer. Yeah, we should put them on a separate sheet of paper. So it's going to take me just a little bit to copy them, so catch you on the flip side. All right, hell yeah. But we gotta rationalize this. Let's just try to do it kind of fast. We're going to put a square root of 2 up top. This becomes 2, so let's just say it becomes 4. Cool. We got to put a square root of 2 up top. This becomes 2, so just do that. Put a square root of 2 up top, and this becomes 2. All right, see, because we had to multiply by the square root of 2 top and bottom, and then multiplying by the square root of 2 times square root of 2. And another way to do this, anything under the square root and is a multiplication, you can just do this, 2 times 2. So just a lot of different ways to say the same thing. That's how this would be the square root of 4. That's how if you have a number, how the hell do you get stuff out of the square root? Well, you can say this is the square root of 2 times 2. Cool. And then you can say that's the square root of 2, square root of 2. And sometimes, like here, you can't get anything out. If you had square root of 8, hell yeah, you can get something out, because this is going to be equal to the square root of 4, square root of 2. Or well, I guess you would do it this, 4 times 2. And then you could say that's that. And then you could say square root of 4 is 2, and you got something popped out. We don't really have to do that for today's video. So we got this rationalized. This is our third equation. And so booyah. But since we have this on the page, we have S1, S2. We know L. We have S1, S2, S3. Cool. And we have S2, S3. So we just have 3 unknowns, S1, S2, and S3. And we got 3 separate equations. So this is where you get, but it's a little bit monstrous, especially when they require you to keep track of all the, rationalize the denominators, making sure all your answers have a rationalized denominator. And yeah, it's just a lot of places really tedious. So let me recopy these three equations, and we're going to see how we're going to put them together. All right, hell yeah, let the games begin. Now, you know what I mean? It's just like, why do we not get to see the problem? Well, this is the deal with problems. This is why in my longer video, you want to do a lot of like analyzing and see it guesswork, you know what I mean, just to get a feel for the problem. Because the second you get something like this, you kind of forget about the problem and you're just trying to fight for an answer. That's why most engineering problems give you the answer, so you kind of attack it from both sides. Now, there's a lot of ways that I would like to teach where you don't have to be given the answer, because there's so many physics problems that you can, you know, use rough guesstimates, you know, to do it. But anyway, we got our three equations and we got our three unknowns. So now here is where you want to get like kind of strategical. So this has S1 and S2, so hell yeah, I would just want to solve for one of them, okay? And so just don't do that right away, because you're like, well, then what am I going to put them into? The one that I look for is like, is there an equation that has everything? Yes, this one has S1, S2, and S3. Sweet. And so, I mean, like the first thing I did is like, well, let's solve this one for S1. But if you solve for S1, that doesn't mean that you're going to be getting S1 at the end. Because if I take everything to the other side and solve this one for S1, I'm going to maybe put it into here. And this now becomes a function of S2, this is S2, and then I have this as S3. So then I'm going to solve this one, because this just has S2 and S3. I'm going to solve this one for S3, and then shove it into S3 right there. And especially since I can solve this one for S3, and then I just shove it individually. If I solve this one for S1, then I have to shove it into here and then multiply it by even that thing, which gets a little bit headachy. Okay, so here we go. And hopefully we make some mistakes. You never know. And how many, you know, I mean, should I try to do every step? If I got those over there, they would just be added over there. I think it's better to actually see if you can do a few steps at once, but if you can't, it's all right. Because I have to tell myself that, because even this is just a little bit headachy. If those are over there, I'm just adding them. So I'm just going to, like, you know, show that. And then to get S1 by itself, I got to multiply by 5 and divide by 2 square roots of 5. So let's do that. So I think I can do this in one step. I can say S1 is multiply by 5, divide by 2 square roots of 5. So that's all I'm looking at. And then I say, what am I multiplying? Well, these are both going to be positive. And so I'm going to say it's the square root of 2 divided by 2, S2. And now I have plus, same thing, multiply by 5, divide by 2 square roots of 5, and then multiply by this. So I did a couple steps right there, but not too bad. Cool. I would probably show those steps. Get those terms over there, and then divide and show that division. You know, even just, you know, put this underneath, and then kind of factor it through. Cool. But even here, we want to kind of rationalize the denominator. So if we do that, we're going to have a square root of 5 up top, square root of 5. We basically have to just multiply everything by the square root of 5 to get this denominator to be the same. So now these two terms don't become 25. They just become 5. Cool. So those two terms become 5. Those become 5. I even made the mistake. I thought this was more than, you know, I thought, oh, this was 20. I don't know what the hell I was thinking. But anyway, 5 times 2 is 10 times 2 is 20. Cool. And we're going to have kind of the same thing. So if we can do 2 steps at once, that's going to be 20. The top is going to be 5. And then it's going to be the square root of 2, square root of 5. So we got 5 divided by 20. See, I'm doing too many steps at once, but I just want to get on with life too, because I did the 5-hour video today. But it doesn't tackle your specific solution. So this is kind of cool. But anyway, this just becomes 4/5, right? You know what I mean? Divide by 5, this becomes 1/4. Sweet. 5/20 is 1/4, right? 5/20. Yep. Because if 5 divided by 5 is 1, 20 divided by 5 is 4. Hell yeah. See, I'm just doing way too many steps, but let's do this. So S1 is the square root of 2 square root of 5 divided by 4. Yeah, too many steps. Sorry about that. But that's going to be S2. Now this, okay, so this is going to be 5 times 2 is 10 times 2 is 20. So we're going to have 5 divided by 20 times this. 5 divided by 20 is 1/4. So we're going to have square root of 2 square root of 5 divided by 4 L. Hell yeah. So we simplified that pretty good, you know what I mean? And that's going to be S1. And we modified this equation. So sometimes I just do 1 prime. Boxing it in kind of helps. It kind of smooths it out. Now I'm going to get this equation in terms of S3. And holy, this has got to be equal to 0. Sorry about that. And there's from the page before. Ah, shoot, where is that? I quickly rationalized this. You know what I mean? This had a square root of 2. This had a square root of 2. We got the square root of 2 up top and bottom. This becomes 2. But now this is 2 square roots of 2 divided by 2. So these 2's cancel. And that's the only change from this side. So the moment equation is just this square root of 2L minus square root of 2L. But the moment equation still is equal to 0. Sorry about that. All these equations are equal to 0. All right, booyah. So, yeah, and I think this is good because, you know, me kind of jumping over steps, I don't know, because then you're not just having every step spoon-fed to you. But yeah, it's good practice to be like, oh, hell yeah, I'm going to write this on a new line, equals, and then add those to the other side. And then I'm going to, on a new line, write that stuff on the other side, and then divided by this fraction, 2 square roots of 5 divided by 5. But dividing by a fraction, you could do another line, is multiplying by the reciprocal. And then FOIL that through. You're going to multiply by 5 up top, and that's what we did in one step. We said S1 is equal to this term right here, multiplied by 5 divided by the 2 square roots of 5. And that's what we did. And then with this extra space, I'm like, hell yeah, I'm just going to rationalize. And that's what we did. But just, I wouldn't combine these because we're going to cancel them out in the end anyway. So yeah, I would keep that separate. Okay, hell yeah. So now we're going to get this in terms of S3. All right, booyah. And then how many steps can we do at once? I don't know. I mean, let's see if we're going to have S3. I mean, we just have a 3S3. So S3 is going to be, hell yeah, let's just get that term to the other side. That's going to be a minus this term. And we're going to be 5 square roots of 2 divided by 4 S2. So now that term's on the other side, but we would have to divide by 3. So sweet. So do that. And we're gonna divide by 3. This becomes 12. Hell yeah. And so that's how I can kind of do this in one step. And I'm going to, because it's good, you know, just to like, hey, put 3S3 on this side, move all the other terms over to the other side. I mean, that's the thing where it's just like, but I don't like this method where it's just like there's no, like I said, the second we stop looking at the problem, it's just a tedious, you know, way to get a solution. So that's why my long videos, I like it, because it's like, it's not about this tediousness. You know, we already learned something before we got here. But this is an okay process too of being like, hell yeah, we have sum of the forces in the y, x, and we took moments. We have 3 equations. Like, there's nothing wrong with this. That was the cool thing, because I thought this problem, he said like it was so complicated and stuff, where I just didn't think you could use a method like this. I thought you needed a 4th equation. You know what I mean? Like, you know, like I was doing over there. But it turns out you don't, but you just have a lot of keeping up with this busy work. And with all this talk, but I am still going to skip steps because I can't write, well, I've been writing all day, but yeah, I still don't want to get like carpal tunnel. All All right, so hell yeah. So, you know me, let's do this. So we have S3 is equal to that on the other side. That's going to be a negative this on the other side we divided by 3. Cool. The next term is this one. So we're going to add that. Add 5. Got to make sure to divide by 3. L. Add this. Plus 5 square roots of 2. Divide by 3. We got a 6 now. L. So I did 2 steps there. And then get this to the other side. So we have add it. Square root of 2 divided by 3. Oh, this has L2. Cool. So now we have S3 in terms of this. It's all rationalized. So yeah, we're pretty sweet there. And yeah, we're done. You know what I mean? Good enough. But I think this problem I would rationalize at least all the way through. And this was a modification of this third equation. So we don't get an extra equation. That's why it's good to put the prime. So 1 prime was a modification of 1. We just solved for S1. This we solved for S3. And now we're good to go. We're going to put 1 prime and 3 prime into 2 prime. Into 2. Into equation 2 has S1, S2, S3. And now, when we throw in S3, this is just in terms of S2. This one is just, so now we can put them into here and solve for S2. And that's going to give us this legitimate answer. And hopefully I made at least one mistake. I don't think I did. We're looking pretty good so far. So I've already done this and just kind of keeping track of what it looks like. Okay, but this is tricky because now I have S1 is this, and we got to multiply by the square root of 5, and a negative. But anyway, let's just start writing S1. We have the square root of 2, the square root of 5, divided by 4. We have to multiply by this jazz. It's got a negative. We have a square root of 5, and then divided by 5. All right, sweet. And we have an S2. Cool. Our next S1 term is this. So we're going to go next S1. I don't know what the plus or minus is, but we got square root of 2, square root of 5, divided by 4. Now we got to multiply this because we're shoving this equation right into that little guy. And we still got to multiply by a negative, then the square root of 5, and 5. I mean, this problem, you could do line after line after line of just doing like one little thing. You know, so I'm trying to do like at least 2 things at once. Cool. And we have an L. Okay, hell yeah. Now move on to the next one. Maybe write a little bit smaller. We have minus the square root of 2, S2. We're in terms of S2, so just moving on. Minus L, minus the square root of 2, L. And then we got plus S3. And this is where it's like, I ain't writing this, so this is what I did. I just said plus all this. You know what I mean? Because like, that's the crazy thing about a solution like this. What do you want to just write? Like a novel, just to show every little step. Okay, but this is going to be equal to, what is this? This is going to be equal to a 0. Yeah, so all this stuff, we just started on this side, all this stuff is going to be equal to 0. So now let the games begin, and we're simplifying. So this just becomes 5, and that 5 cancels with that 5. Sweet. This 5 cancels with that 5. Sweet. Hell yeah. And everything's rationalized. We got a square root of 2, 4. Sweet. And then everything up here is looking good. So, I mean, again, I really should be writing like 4 or 5 steps, but we just have to get on, and I've already done this problem a couple times. What I'm going to do, I mean, you would just write it all out, at least get it on one line, and then you would see you would have, this is S2, this isn't. L is known, so we have S2, S2, S2. Everything else is L's. Cool. So what I'm going to do, and what you're going to do is you're adding fractions now. We have a something twelfths, a something third, a something sixth, a something third, a something fourth, half, half. So we just need them all the same, might as well. So 12 is the lowest common denominator, so I'm going to do that as well all in one step. So I'm going to start here, and I'm going to do minus, and then I'm going to factor out the S2. So sorry for doing too many steps at once. But yeah, all we have is this equation. You know, this equation number 2, we started plugging it in, we got to S3, and we're just saying, hey, that goes right there. Still equal to 0. Cool. So the first thing to factor, this one has an S2. So we have negative square, so if we make this 12, we got to multiply by 3 top and bottom. So we're going to have negative 3 square root of 2 divided by 12. And we already factored out the S2. The next S2 term is here, and so we have a negative 12. We got to multiply by 6 top and bottom. 6 square root of 2. But yeah, I can't do this like first try. But it is, yeah, so anyway, but I'm doing pretty good. I'm probably pretty slow, actually. No, I think we're doing pretty good. So those are the only terms that have S2, but we are adding also this thing, which has this term. So we got minus. And now I feel like I did make a mistake. But no, I mean, yeah, maybe it was just minus, minus, minus. I don't think it was. Just kind of double check here. Yeah, these are both going to be minus. S3, that moment, yep, it's going to be a negative moment. Yeah, the moments were negative, positive, negative, negative. All right, cool. Sometimes you freak out just because something looks a little bit different when you've already done it once or something. Okay, so we have that term. It's already with a 12, so we got negative 5 square root of 2 twelfths. Cool, we factored out the S2. And now, might as well, we're going to do 2 steps. Sorry for doing too many steps at once. Now we're going to get all the L's to the other side. Because we need to get this by itself, get all the L's to the other side, and then divide by this thing. I mean, tedious, but okay, this is a function of S2, so we need to get this to the other side and make it also a factor of 12. So we're going to be 3 square roots 2 divided by 12. It was negative, now it's positive. We have an L. This becomes positive 6 square, oh, sorry, that's an S2 term. So now we need this one. So we have positive 12 twelfths L. And then plus 6 square roots of 2 twelfths L. Hell yeah. And then, alright. And then we're going to minus, multiply by 4. So 20 twelfths L. And, sorry, I'm going to get kind of small. We're going to do one more minus. 10 square root of 12, 10 square roots of 12, square roots of 2 twelfths, and then minus, we got to multiply this by 4 top and bottom. That's going to be 4 square roots of 2 twelfths. Hell yeah. And now the 0 is no longer not equal to 0 because we got all the L terms over here. All the L terms and then the terms that, no, they should all have L. No, is there terms that don't have L? I don't think so. No, everything has an L. Sorry about that. Cool. But, okay, so now everything has a 12, so we can just cancel that out. Hell yeah. And now this is where you kind of add oranges. You know what I mean? This is square roots 2. We got everything with square roots 2. It's like adding oranges. We have 3 oranges, 6 oranges, 5 oranges. Well, we have minus 3 oranges, minus 6 oranges, minus 5 oranges. And so we have 6, 9, 14. So we got negative 14 square roots of 2. We've already factored out the 12 because it's on both sides. You know what I mean? So that was kind of cool. Over here, we can only add oranges. So we got a square root of 2 here. So we got 3 plus 6. 3 oranges plus 6 oranges. That's going to be 9 square roots 2. And then the things that, oh, no, we have plenty. So we have 3 and 6. That's going to be a positive 9. And then over here, we have a negative 10 oranges, a negative 4 oranges. So we got negative 14 oranges. So 9 minus 14 is negative 5. So we have negative 5 oranges. That's the negative 5 square root of 2. Cool. And so those are all the terms with the square root of 2. The only thing that doesn't are these two. We have a 10 minus 20. So that's going to be a negative 8. We have negative 8L. So over here we got negative 14. Oh, hell no. No. We said plus 9 oranges minus 14 is negative 5 oranges. Negative 5 square root of 2. So we have negative 5 square root of 2 plus 8. All these had L's in them, so I'll keep the L's right there. Sorry about that. And this is going to be equal to this side, which was just negative 14 square root of 2. And it was, times S2. All right, hell yeah. And I'm sorry, it's late at night and I already kind of did a 5-hour video today. I just wanted to bust this out because you specifically got to this point of having the 3 equations, and I mean, this is like, I don't wish this upon anyone. Like, I think, if the teacher, but it's cool because there's many ways to do this, and I don't know. Like, I wouldn't be able to do this in college at all. Like my first try, it'd be too maddening. You could make too many mistakes, and it'd be maddening. But anyway, and we haven't even finished. So we have S2. I will do this in a couple steps. Is this negative 5 square roots of 2L plus 8L, and then we're going to divide this side, minus 14 square roots of 2. Now here you got some options. You could multiply. You could rationalize the denominator by doing this, the square root of 2 times the square root of 2. You could do that, or let's say you didn't do that. Both of these terms are divided by a single term. So we could have negative 5 square roots of 2 divided by negative 14 square roots of 2. And who knows if I made an error. That would suck. It would be sweet if I didn't, just because I want to be done. Yeah, because the longer video is way cooler. Cool. And then we got, and is that a plus? Hell no. See, why am I messing up? No, we had a 12 minus 20. So this is a negative 8L. So, yeah, I knew there was like negatives galore. But that's the other thing. If there's negatives galore, we could, multiply by a negative 1 top and bottom. Cool. So that gets rid of the negatives. And so let's do that. So we're going to have a positive 5 halves divided by 14 halves plus 8 divided by 14 square roots of 2. Yeah, I just think this side got messed up. I swear it's like off by a positive, but maybe not. I don't think so. All right, so, no, hell yeah, it's off. But what do you do? No, we did it right. But yeah, we got an error somewhere. Sorry about that. But let's keep plugging it out like we got the right solution. But we don't. That's a bummer. So we would, yeah. Now I got hella. Yeah, that got hella messy. Oh yeah, and so now the denominator. Oh, no! Holy hell! Now I think you want to do it this way. You want to rationalize the denominator. And so then we have negative 14 times 2 is negative 28. Yeah, we're off by something. So we're going to have 28 downstairs, and then we have 5 up. I'm going to get rid of the negatives. We have this, so we have 5 times 2, so that's 10. So we have 10 plus 8 square roots of 2. So we can simplify this, and it's going to be 5 plus, divide by everything by 2. 5 plus 4 square roots of 2 divided by 14. But it's not 14, it should be 4. You know what I mean? Because the answer is 5 plus 4 square roots of 2 divided by 4, not 14. That's where I was wigging out about a division sign. So I think I can do that on camera, though. So let's go back to the original problem. All right, hell yeah. And this is always a good skill. So we have equation, sum of the forces in the x, we're going to have a positive S1. a negative S2. And then we're going to have a negative L component. Sweet, so that one's checks. Some of the forces in the y direction. We're going to have a negative S1. We're going to have a negative S2. We're going to have negative L's in the y. And then we're going to have a positive S3. Okay, that checks out. So I think it's where the sum of the moments. We're going to sum about A. This is going to be a negative moment. So we have that negative. This is going to be a positive moment. And then the L is going to be negative. All components of the L's are negative. And we have 3 components of the L. Cool. So here, yeah, there's my error. I have a negative right here, and I just boxed it in. See how, like, negatives are the devil. But there you go. So we got a negative right there, and that's the one we missed. But that's kind of cool. I'm glad I made a mistake because I'm pretty good at finding them. So cool. So this was equation 3. We modified equation 3 right here. So to get S3 by itself, we had to get that term to the other side. This becomes positive. Hell yeah. And now once we had this is where we threw it in right here. And we said this was an S2 term. That's going to be right. That's the last thing we did because we used this equation. We got the S2, 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 and then we had the L's. Anyway, so that's this term right here, which should be a positive. Cool. So now we're adding the apples and oranges. We have negative 9 plus 5. So now we have a negative 4 apples. So we're still in the boat where, like, hey, this is a negative 4, right? And so everything just matches. This is a negative 4 S2, a negative 5 square root of 2 minus 8L. And this is negative 5 square root of 2L minus 8L. So right now you could just factor out the negatives. And now we'll slow it down just a touch, but basically, there you go. So we have S2 is equal to, this side is 5 square roots of 2L plus 8L. And now we're going to divide this side, which is now just a positive 4 square roots of 2. We want to rationalize the denominator, or as we said, we could divide this and this, and when you do that, this is going to go away, and you're going to have 5/4 L. I mean, so we could do that so we could have 5/4 L, but then when you divide this, you're going to have plus 8/4 L divided by the square root of 2. So you're still going to have to rationalize at least one thing, but I mean, maybe it's easier just to rationalize one thing like this. And so this is going to be 5/4 L plus, this is going to be 2. And so it's going to be 8 square roots of 2 divided by 8L. Holy hell, I feel like I'm also doing wrong things. Okay, no, there you go. And so, cool. I mean, but maybe you want this as a fraction, right? And so to get it as a fraction, you would need this denominator to be 4. So it would be 4/4. I feel like I did something wrong here too, but cool. And now we can add these. And you're going to have, and we're going to get this one first, 4 square roots of 2 plus 5. And then this is going to be all over 4. And then this is going to be all multiplied by L. So hell yeah. So that's going to be the solution for S2. Sweet. Holy Toledo. I thought this was going to go smooth, but nope. And I mean, like, I think I spent too long saying I'm going to skip steps and then just like kept on saying that. Where I could have just wrote the steps more, but now I'm fine with that. Sweet, so yeah, that's going to be the answer. The other way to do is just rationalize from here. I'm just going to multiply by the square root of 2, multiply by the square root of 2. So this is going to be 8 on the bottom, so we're going to have 8 on the bottom. This is going to be 5L up top. No, sorry. These two multiplied are going to be 2, so this is going to be 10L. And then this is going to be plus 8 square roots of 2L. So this is where you can divide by 2 because this will go to 5L plus 4 square roots of 2L divided by 4. Yep. Yeah. I mean, I'm tempted to, do this one again line by line. But all we did is we got S2, you know what I mean? So sweet. So now we have S2, you can show that. And now we probably have to go back to our equations right here. So let me throw in a new battery. All right, hell yeah. So let's, and I haven't gotten past this part, so I might make a lot of mistakes, but this is the answer for S2, and it's in this form. But, I mean, how awful is this form anyway? I mean, I can't even insert it into the other equations. So what I did is I just divided each term by 4. So this is going to be the square root of 2L. And then 5/4 L. And that should be what we would have had anyway. Hell yeah, I see that. That's square root of 2L. And then 5 divided by 4L. You know, I mean, we could have seen that maybe a lot sooner. Anyway, okay, but we have this term for S2, and we have all the equations that we had. And so now we can solve for S1. Like, this is the equation that just has S2 and S1. We got it in terms of S1 right here, so let's do it. Let's solve for S1. So S1 is going to be the square root of 2 square root of 5 divided by 4 times one of these, square root of 2L. Plus, we have two terms here, so we need to do this again, the square root of 2, square root of 5, 4, times, I'm just blanking out, but no, it's 5/4 L. Cool, so now we just did those two terms. Okay, now we're going to add square root of 2, square root of 5, divided by 4L. Cool. Now, and we got to, now we got to, this is 2, and, cool. So that is 2. Yeah, so let's do this in just a few steps, which I didn't do before. So now we have 2 divided by 4. I'm just going to simplify, well, no, this is 4 divided by 4. So that's the other thing. It's like we have to rationalize the denominators. They're rationalized. And then the next step is to common denominators. So the common denominator here is 16. So I could just do this right now. 16, 16, and then make sure this is multiplied by 4. 16, 4. So now we have 4 times 2. So this is 8 square roots 5. Hell yeah. So I'm going to have 8 square roots 5 divided by 16. L plus, this is going to be the square root of 2 square root of 5. And we're going to have 5/16 that. Okay, L. And then plus, so now instead of, once we get to this step, I'll talk about apples and oranges. All right, so now we have 4/16. So we got 4 square roots of 2 square roots of 5/16 L. So now I only have a square root of 5 here. So this is an orange. And then, but damn, this is basically square root of 10. You know what I mean? So this is 2 pineapples. So there's only one orange, but we got 2 pineapples. So we can add the pineapples. So we got 5/16 of a pineapple, 4/16. So cool, we got 9/16 of a pineapple. All right, so we can at least go that far. So we have 8 square roots of 5, 16L, plus, what do we say, 9 square roots of 2 square roots of 5, 16L. Hell yeah. And, this would be my solution, and you're done. S1 is going to be this. But then, you know what I mean? If you want to take a peek of how they did it, you're like, well, let's get it all in one stupid equation. That's useless. No, I don't know. But anyway, so how would you combine these? You know, that's why this problem, it's, I think they want you, but this is the most tedious way, I swear, to do the 3 equations, and it's just monstrous compared to finding a different way that might be just a little bit simpler, where your fractions are just a little bit nicer to get to. Okay, hell yeah. So how do we combine these? The denominators are the same, so we can just add them straight across. Oh man, let's grab another sheet of paper. So we're gonna have 8 square roots of 5. And I can factor out the L, you know, I mean, they do that at the end anyway. 9 square roots of 2, square roots of 5, divided by 16, and now you have the L out here. And is there anything else we can factor out? Not really, but you can factor out a square root of 2. Yes, I see this term and that term. Hey, it's in both the top and bottom, so let's do that. So, and this is S1 again, so S1 is going to be the square root of 5, you know, and now we have 8 plus 9 square root 2 divided by 16L. And so that's what they have there. S1, and you know, the negative means compression. That's why it's weird to say compression and then have a negative. You know, you should, I mean, if you say compression, I mean, I don't know. It's like, I just put the vector in the negative compression direction. What they did is put all the vectors in the, you know, the tension direction. So even this S3 would be in a tension direction. This one would be a tension direction. And then when you solve for it, it would come up with this negative value. So I'm just, forget that, or maybe you want to do it that way, but I'm just, hey, I'm getting positive values because my drawing showed that those are in a compression. And even in my long video, I kind of proved that they're compression anyway, so we guessed right in the beginning, and I don't have to just assume tension on everything. Oof, yeah, and I hate negatives. Okay, sweet. So, yep, so there's the answer for S1. We have positive, my answer is positive, square root 5, bracket, 9 square root 2 plus 8. So I guess they just switch those two terms around. And maybe that's common. Put your square root term first and then your other terms second. And then divide by 16 multiplied by L. Okay, home stretch. So that's going to be, I'm going to write, how are we going to get S3? What equation has S3? This one does. That's a beast. But that's the one that we solve for S3. And the only other term here is S2. And cool. And we have S2 right here. So let me rewrite S2 and we'll just go for it. Yeah, in S2 we wrote S2 in kind of in a friendly manner. Square root 2L plus 5/4 L. But it's just wild how you can write these in so many ways. Like if I wanted to combine these, I need to get the denominators the same. Cool, and now I can make a crazy equation that says 4 square roots 2 plus 5 divided by 4. You know, and then it's just really hard to work with. Cool, so this is S2. And we're going to solve for S3. So S3 is, alright, so we're going to have 5. We're also going to multiply, no, I guess 5 square root 2 divided by 12. I got that. This is S2, it's both terms, so we got to multiply by the square root of 2L. Cool, and then on to this and this. So plus 5 square root 2 divided by 12, multiplied by 5 divided by 4, and then we have L again. Cool. And now everything's in terms of L, we just have kind of that apple-oranges, you know, combination. We can even kind of look at the answer, S3. It only has oranges, you know what I mean? This one had oranges and pineapples. This one just had oranges. And then just normal numbers. Holy hell. Okay, so we have, cool. Cool, we just did this S2 term. Now we have plus 5/3 L plus 5 square roots 2, 6 L plus the square root of 2, 3L. Alright, so now, sorry for writing so sloppy, but, maybe simplify. So this is going to be 2. So this is going to be 10 twelfths. Cool. This is going to be 10. This is going to be 10, but divided by 4, that's 5 halves. And then we have 5 24ths. Really? 5 24ths, eh? What? I feel like I did something wrong on that one. We had 5 halves, 12, and then we multiplied by our, 5 fourths. Oh, see, I'm messing up. This is 25. I don't know why I do that. This is going to be 25. No, we did it right, but 25 divided by 48. Oh, man, right at the end. Oh, it just feels like it's not right. Oh, did we change our negatives? Because what was our equation that we had to change up? Wasn't it our moment equation? Yeah, we modified this equation for S3. Yeah, and we did. We got this plus. This was a negative, and we finally got it in, and then we turned it to plus. Oh, why am I losing my mind on this? Okay. And we have S2. S2 is this. And it's going to be square root of 2 plus 5 fourths. Cool. Is that what we have? Square root of 2. So we did it. We had 5. We had that. Square root of 2. And then we have this again times 5 fourths. Yeah, I guess so. Oh wow, I'm just getting kind of tired too. All right, let's just go with it. So let's start to just redo this one. So we have 10 twelfths. L. What did we say this was? Ugh. This is going to be 10 divided by 12. That's at least going to be 5 divided by 6. And that's going to be 5 divided by 24. Wait, how could we... This doesn't look... this doesn't look... whatever you call... But why can I do 10 divided by 12? Because these aren't 10. I don't know why I'm doing that. Holy Toledo. So it's just 25 divided by 48. Square root 2. Oh, no, I get it. We're going to add the oranges. You know what I mean? That's where it's just like, why do I get to something like this and just like, have a fit? I mean, it just doesn't look right or something. But no, we're probably going to add something else that's a denominator of 48. I haven't done this problem. Actually, I just got S, so why am I... Yeah, that's so weird when you're just like, you just assume something's wrong, but no, it's not. And then you start saying 5 times 5 is 10 just because you want to start canceling things. Wow, that's insane. Okay, so we have plus 5/3 L. Cool, yeah, so this term we got those two terms because of the S2 that we inserted, and now we're just adding the rest. And we'll probably have to come up with a common denominator. So this is going to be square root of 2 divided by 3. And might as well just turn this into 12 4 twelfths. Give us a head start. Because our common denominator is 48. So we need to multiply by this by 4. So we're going to have 40L divided by 48 plus 25 square roots of 2. 48L plus, see even this, I have a hard time. This is 10 sixths. It's going to be 20 twelfths. And then it's going to be 48. That's going to be 80. 4 times 20 is 80. So we have 80 48ths L. That's what that one was. Okay, this one is going to be 10 12ths. 48 is going to be 40 48ths. So 40 48ths L. Oh, we got that square root of 2. You know what I mean? These are our oranges. We got to add all our oranges up. Okay, hell yeah. Plus, we got 4. So we got 48. We got 16 square roots of 2. So hell yeah. So now we get to add our oranges. We have 25 oranges plus 40 oranges plus 16 oranges. So this is going to be 56. 56 plus 25. 5, 6, 7, 8. That's 81. And hell yeah, 81 is divisible by 9. Man, it's not divisible by anything else. Whatever. Okay, so we have, yeah, no need to fret. So that's what we have for our oranges. We have 81 48ths, because it's all positive. I don't think there's a negative on here. We're just all positive on that one. And that's what we thought. You know, back to the basics. Yeah, why is S3 such a large magnitude? Is because, you know, everything is pulling down on it. This is down, this is down, this is down. You know what I mean? It's like this is the teeter-totter, and that's in the longer video I did that. Heavy weight on a teeter-totter, even if you have a string connected to the ground, heavy weight, this is the same sort of weight pulling down. So this teeter-totter, this support has to see 2W, twice of that one load over there. I mean, even though it's pulling up. So that's what the leverage effect, you know, there's no load L over here, but because this is leveraging it, you can do a teeter-totter and just make a rope to the ground, and it's like there's a second person over there. And that's so bizarre, isn't it? Where this structure or support will feel 2 people, even though one's not there. So it's pretty cool. Alright, that's the stuff that I enjoy. This is so tedious, and I feel like we're going to get it. Alright, so now we're going to add the things that aren't oranges. Those are the 3 things that were oranges. The things that aren't are 80 plus 40, that's 120. 120, 48, that's going to be 60, 24. See, I'm pretty bad at this, but we got 30, 12, 15, 6. Cool. So I'm going to have 15 6th L plus 81 48ths. Oh, I did something wrong. Holy Toledo. Okay. But maybe I can get this back to 48. So this is going to be 120. So this is going to be 120 48ths L. And now I can add these together. So I'm going to have 81 square root 2, 81 of those oranges, plus 1/20th divided by everything by 48, and then multiplied by L. But I'm sure I did one thing wrong, because this totally does not look right. 81 is a factor of 9 and 9, which is a factor of 3, 3, 3, 3. They have a 27 on here, so we're close, because that's 3 times 3 times 3 is, yeah, that's 9 times 3 is 27. But for whatever reason, our denominator I can't factor by 3. Or can I? See, that's how bad I am. Is 16 times 3 48? I'm going to lose my mind if it is. 3, 4. That's 48. I don't see that. See, that's why people say stay away from the calculator, because I do not see that 48 is a factor of 3. But I could say 8 plus 4 is 12. 1 plus 2 is 3. Must be a factor of 3. Alright, hell yeah, so we did it. But that was so wild, like right at the end, I just feel like, nah, there's no way in hell. But hell yeah, so we can factor out a 3. So we can say this is, I can, top and bottom, I can divide 81 by 3, 48 by 3, 120 by 3. I don't even know how to divide 120 by 3. Is that 40? I was going to say 60, but hell yeah. So this is going to be 27 square root 2 plus 40 divided by 16, once you know it, multiplied by L. That's going to be S3. Man, that just got harder and harder the entire way. Hell yeah. All right, so we did it. So, and we don't have any negatives because we knew that this was going to be in compression. And we're saying compression is the positive arrow direction on my arrow. So that's the only discrepancy we have. I mean, these are just qualifiers. It says, hell, you know what I mean? They didn't draw arrows either. So it should say, assume all arrows are in tension on the blue box. I think that would be written qualifiers that I think would be helpful. Instead of saying negative and then compression. It's like saying a negative of a negative. I do not like that. All right, sweet. So we did it. We have square root 27 square root 2 plus 40 divided by 16 L. That was cool because and I think you wanted that too. You didn't want me just to like have this all written out or even just go slow as hell because there's a lot that you're just like, no, I want to do that. I thought this was going to be 20 minutes, but no, I think that was more than an hour, and I apologize for that. But yeah, I did not like that solution. I love my 5-hour solution, and hopefully that loads. But if I can load this faster, this is what you get. First, yeah. But isn't it bizarre that once you get the 3 equations, 3 unknowns, you do not learn anything about the problem from that point forward. And it's all just grinding and not making mistakes. But I think that was the purpose of this problem, is like, hey, how many times can you add fractions, rationalize, add oranges, throw in a pineapple, add some pineapples together, you know, and then just factor everything out. But I think you know, it sounds dumb, but yeah, when you're adding fractions of square roots, I think that's pretty good. You can add these. They're 2 oranges, and this is a pineapple. And we had a case where we had 2 of those pineapples. We added those together. That was part of this equation right here. All right, hell yeah, I'm done with this one. No, we're going to do more videos on this, probably shorter videos.